Chapter 10 Network Management. There are 7 sessions in this chapter. 10.1, that's the device discovery with CDP. 10.2, device discovery with LLDP. 10.3, NTP. 10.4, SNMP. 10.5, that's the syslog. 10.6, router and switch file maintenance. And then the last session, 10.7, that's the iOS image management. Without further ado, let's start. 10.1, device discovery with CDP. When managing a network, one of the first questions you should ask is, what devices are on my network? What are those devices located? And how are they connected? To answer these questions, you need a network map. Cisco provides a tool called Cisco Discovery Protocol, or CDP, to help build that map. So what is CDP? It stands for Cisco Discovery Protocol. It's a Cisco proprietary Layer 2 discovery protocol. Its purpose is to discover information about directly connected Cisco devices. CDP allows neighboring Cisco devices to automatically exchange information without requiring any IP configuration. The key characteristics of CDP. CDP has several important characteristics. It is a Layer 2 protocol. It is Cisco proprietary, meaning it works only on Cisco devices. It is media independent, so it works over Ethernet, serial links, fiber, and other supported media. It is protocol independent, meaning it works even if Layer 3 protocols, such as IPv4 or IPv6, are not configured. Devices that support CDP. CDP runs on many Cisco devices, including router, switches, access servers, other Cisco networking devices. As long as 2 Cisco devices are directly connected and the CDP is enabled, they can exchange neighbor information. Cisco devices use CDP advertisements to share information with directly connected neighbors. As shown in the figure, the router and the switch send CDP messages to each other across the local link. These advertisements are sent periodically and also automatically when CDP is enabled. CDP advertisements provide useful information about directly connected Cisco devices. Each advertisement includes details such as device name, device type, device capabilities, number and types of interfaces, and other useful system information. By exchanging this information automatically, neighboring devices learn about each other without requiring manual configuration. For Cisco devices, CDP is enabled by default. For security reasons, it may be desirable to disable CDP on a network device globally or per interface. With CDP, an attacker can gather valuable insights about the network layout, such as IP addresses, iOS versions, and the types of devices. To verify the status of CDP and display information about the CDP, enter the show CDP command, as shown here. So after entering the command in the configuration mode, you see like global CDP information, such as sending CDP packets every 60 seconds, sending a hold time value of 180 seconds, also sending the CDP version 2 advertisements is enabled. To enable CDP globally for all supported interface on a device, you can enter the command CDP run in the global configuration mode, and the CDP can be disabled for all interfaces on the device with no CDP run command. as shown in the example here. This example shows how to enable CDP of a particular interface, such as the Gigabit Ethernet port in a switch. So first, in the global configuration mode of that switch, enter the command interface and then specify that particular interface. In this example, that's the Gigabit Ethernet 001. And then you'll enter into the interface configuration mode and then type CDP enable. To verify the status of CDP and then display a list of neighbors, we can use the show command. Of course, this is for showing CDP. You use the show CDP neighbors, and then the corresponding information will be showing. For example, you can see the capability code R, that's for router, T for the trans bridge, and so on. You can also see the device ID, the local interface, hold time, capability, platform, port ID, and so on. In this example, it shows the total CDP entries displayed. Use the show CDP interface command to display the interfaces that are CDP enabled on a device. The status of each interface is also displayed. The figure here shows that 5 interfaces are CDP enabled on the router with only one active connection to another device. So in the example, in the router configuration mode, you enter show CDP interface, and then this information displayed. The important information shown here shows that the Gigabit Ethernet 0 is down, line protocol is down. And then with the encapsulation ARPA sending CDP packets every 60 seconds, and then the hold time, the CDP enabled devices, that's 6 interfaces up, which is 1, and the 5 of them are down. Consider the lack of documentation in a topology shown in the figure. The network administrator only knows the R1 is connected to other devices. So here, for R1, in the configuration mode, enter show CDP neighbors. With those labels, such as capability codes, which is R, that's router, and then the next section shows the detailed connected devices information. There's one device, switch 1, S1, and then the local interface of switch 1 is Gigabit Ethernet 001. The hold time is 179. Capability, SI platform. Oh, by the way, S, that's switch. I, this is the IGMP. And then it shows the platform, also the port ID, Fast Ethernet 05. Based on the example we just had, we can see there is some information listed after entering the command. These information can be the device identifier, also the device ID. So the device ID identifies the neighboring device. Usually this is the host name of that neighbor. And then we can have the port ID or the port identifier. So the port ID is the interface on the neighboring device. Next, we have the capability lists. The capability field identifies the function of the neighboring device. R stands for it's a router, S indicates that's a switch, and I indicates that's the IGMP capability. At the end, we have the platform. The platform field identifies the neighbor's hardware model. In that example, this indicates it's a Cisco Catalyst 3560 switch. The network administrator uses show CDP neighbors detail command to show the IP address of the switch 1. As displayed in the output, the address for switch 1 is 192.168.1.2. By accessing switch 1, either remotely or through secure shell, the SSH, or even physically through the console port, the network administrator can determine what other devices are connected to switch 1. As displayed in the output of the show CDP neighbors in the figure, you can see these are the devices connected to it. Again, the network administrator can use show CDP neighbors detail to discover the IP address of S2 and then remotely access it. In the example here, in switch 2, you put show CDP neighbors. And after that, you can see switch 1 is connected to it through the fast Ethernet 01 port. And then the hold time is 141 seconds. And then that's a switch capability is S and I. Again, I, that's the IGMP. And then this is a Cisco switch with model 3560. The port ID is fast Ethernet 01. Based on the result, we can conclude that the only device connected to S2 is S1. Therefore, there are no other devices to discover in this topology. The network administrator can now update the documentation to reflect the discovered devices.